In this video, we will learn about black holes and different aspects of them, such as their origin, their properties, and other interesting facts. Make sure to watch the whole video so you can clear your concepts. Black holes are one of the most confusing things in the universe, and they are very difficult to understand. Hopefully, that changes today. A star is stable when the radiation emitted from the core during the fusion process is able to support all the weight above the core and the gravity of the star. During the fusion process, hydrogen fuses to helium, helium to carbon, carbon to neon, all the way to iron. Unlike all the fusion processes before iron, iron releases no energy during the fusion process. As no energy is released, an imbalance is created between the radiation and the gravity, where gravity wins over radiation. This causes the star to implode to the core, after which it explodes into a supernova. A star with 1.4 solar masses, which is the Chandrasekhar limit, will become a white dwarf. A star weighing 2 to 4 solar masses will become a neutron star. This will happen after it crosses the electron degeneracy point. At this point, electrons and protons combine to form neutrons. If it weighs more than that, it becomes a black hole, in which it crosses the neutron degeneracy point. At this point, neutrons are under so much pressure that they collapse into each other, causing the black hole to be formed. Black holes are massive celestial bodies that are formed from stellar death. They have a lot of mass in a small volume, causing them to be very dense. This allows the black hole to have a strong gravitational field that light cannot be returned from after reaching a certain point. This can be understood after we learn Einstein's visualization of space. According to Einstein, space is a fabric of space-time which curves and warps depending on the matter placed upon it. The mass directs the depth of the warp while the density directs the steepness of the warp. A celestial body like the Earth will have a comparatively less steep and deep warp compared to a celestial body like a black hole. The steeper the warp, the stronger the gravitational field. The warp made by a black hole is both steep and deep, making a strong gravitational field. There are three parts of a black hole: the event horizon, the accretion disk, and the singularity. The accretion disk is a ring of space dust, gas, and other debris. This matter revolves around the ISCO, innermost stable circular orbit. In this orbit, matter does not fall into the black hole, but it doesn't fly off into space either. The event horizon is the boundary between space and the black hole. The singularity is the third part of the black hole. This is the center of the black hole. We are not sure what the singularity is made of, but we know that all matter entering the black hole becomes part of the singularity. From Einstein's space, it is the lowest part of the black hole. Black holes can be measured through three parameters: mass, spin, and charge. But we assume the charge is always neutral, so we don't take that into consideration. The mass of the black hole can be determined by its gravitational effects on other bodies. These include other black holes, other stars, or other planets as well. The spin can be calculated by looking at how close the accretion disk is spinning. The closer the accretion disk, the faster the black hole is spinning. What if you fall into a black hole? From an outsider's point of view, you approach the event horizon, and then once reached, you freeze there for centuries, as light cannot travel from the event horizon to the outside world. But from your perspective, you continue to go in the black hole as the black hole starts covering a larger area of your field of view. We don't know what happens next, so the following is a hypothesis. You slowly start approaching the singularity, but now you start stretching because the parts of your body are in different gravitational fields. After this, you die and become a stream of subatomic particles. This process is called spaghettification. Assuming your feet are closer to the singularity, you start to stretch vertically. This happens because your feet are in a stronger gravitational field than your head. The following are some interesting facts on black holes. Every galaxy has a supermassive black hole at its center, which was created by many stars dying and black holes collapsing. All objects can turn into black holes if they are shrunk to a certain radius. This radius is called the Schwarzschild radius. As black holes warp space and time, the time outside the black hole is faster than the time inside the black hole. Hope you learned something new today. There will be new videos on other concepts of black holes soon. Thank you for watching this video.